Good morning, dear student. In today's lecture, we are very much interested in the important studying the important composite material that is concrete. So we are all familiar with this concrete material, but what is this concrete? What is their composition? So let's discuss it. So concrete, it is a composite material. So if you consider, it is it is a composite material. It is a composite material consists of that consists of essentially that consists of essentially of a binding medium binding medium such as such as such as a mixture of portland cement portland cement and water. So these are the two important constituents of this concrete. One is Portland cement and second is water. And within which so we can within which within which some within which we are embedded embedded particles such as aggregates agree such as aggregates such as aggregates Okay, so what is this concrete? It is a composite material that consists of essentially a binding medium such as mixture of Portland cement and water, within which we are embedded particles such as aggregates. So if you consider this concrete, okay, the important constituents the constituent okay important constituent of concrete is your first, that is your cement. Okay, second, that is the important constituent is your uh, water. Then third one, we have to add some aggregates material particles, aggregates. Then we have to add certain admixtures, and the last one, that is we have added certain okay, so these are the materials. Admixture is there. So whenever we consider the concrete, it is made up by cement, water, aggregates, and admixtures. So let's discuss one by one in shortly how this material, or what is the composition, or what is the concentration of the cement, water, aggregates, and admixture. What is their role in this concrete? So it is a composite material made up of by, generally the important constituent is your cement and water, within which we are added aggregates and admixtures. So if we consider the first component, that is cement. Okay, the first component, that is your cement. It is okay. So the most common cement is used in concrete. It is your Portland Portland cement. So cement is the important constituent. Cement, it is act as a matrix for this concrete, and the remaining materials are act as a reinforcement. Okay, so the cement, the most common cement used in concrete is your Portland cement. Okay, this Portland cement, if you consider the second important points, this Portland cement is made up by four mineral components. Made by four mineral components. Four mineral components. The first one, that is the first mineral components, that is tricalcium silicate. Tricalcium silicate. Tricalcium silicate. Its formula is thrice CaO, that is calcium oxide, SiO2, and its abbreviation, it is C3S. So many times the question is asked, what is the full form of this C3S? So what is C3S stands for? So you should remember, C3S means tricalcium silicate. A second one, that is a dicalcium silicate. Dicalcium silicate. Dicalcium silicate, that is twice CaO, SiO2, and it is denoted as C2S. Okay, its abbreviation is C2S. Then the third one, that is tricalcium aluminate. Tricalcium aluminate. Tricalcium aluminate, that is your 3CaO Al2O3, and its abbreviation is C3A. Okay, C3A, tricalcium aluminate. And the last one, that is your tetracalcium aluminoferrite. Tetracalcium aluminoferrite. Okay, the important constituent of the concrete is your cement. It is act as a matrix material for the concrete as a composite. Whatever the cement which is present in this concrete, it is your Portland cement, and it is composed of it is made up by four mineral components, that is tricalcium silicate, dicalcium silicate, tricalcium aluminate, and tetracalcium aluminoferrite, that is 4CaO Al2O3, 4CaO Al2O3, Fe2O3. Okay, and its abbreviation is C4AF. Okay, tetracalcium aluminoferrites. So these are the mineral components of this Portland cements. If you consider its role, that is this tricalcium silicates, okay, it hydrates and hardens rapidly and largely responsible for the initial setting and early strength. Okay, so what is the role of this tricalcium silicate? So the role of these mineral components we will discuss when we studying the cement. Okay, cement is also a cementing material, also we discuss in this section. Therefore, in this lecture we considering the concrete as a composite material. We are not getting into details the concrete as a cementing material. So at least you should know concrete is a composite material in which cement is your matrix and the remaining material is your reinforcing material. Whatever the cement which is used is a Portland cement. The Portland cement is made up by the four mineral components, that is tricalcium silicate, dicalcium silicate, okay, tricalcium aluminate, and tetracalcium aluminum ferrites. The role we discuss in when we discussing the cementing material. The second important constituents of this concrete is your aggregates. So what is this aggregates? Let us discuss it. The second important constituent, so this aggregates, it is act as a reinforcing material. So this aggregates, so what is this aggregates? The aggregates is your granular material. So it is your granular This aggregates is your granular material such as the granular material such as sand, granular material such as sand, gravel, gravel, crush stone, crush stone, or or iron blast, furnace slag. Okay, so what is this aggregates? These aggregates are the granular materials such as sand, gravel, crushed stones, and iron blast furnace. Okay, this aggregate constituent typically 75% of the concrete volume. Okay, the second important point is that uh, the aggregate constituents typically, so this constitute aggregate constitutes typically aggregate constitute typically 75% of the concrete volume concrete wall. Okay, so this aggregate constitute typically 75% of the concrete volume or more, okay, 75% or more. Therefore its properties largely determine the properties of concrete. Again, if you consider, for concrete to be good quality, the aggregate has to be strong and durable and free from slits and organic matters, oils, and sugars. So the important point is that for concrete to be good quality, for concrete to be good quality, good quality, for concrete to be good quality, the aggregate has been strong. What is the property of this aggregate? It becomes strong, then it is durable, strong, durable, and free from uh, slits, organic matter. Strong, okay, it is durable, free from slits, organic matters, oils, and sugars. Oils, sugars. Okay, so these are the important points regarding to these aggregates. Okay, the classification of this aggregate, okay, it is based on the sources, that is natural sources and artificial sources. The naturals aggregates are your sand, gravel, crushed stone, while the artificial is your iron blast, furnace slag. Okay, so this aggregates, okay, the it is an important constituent of this concrete, and it is typically consumes 75% concrete volume, and therefore uh, it is the its property largely determine the properties of concrete. And for concrete to be good quality, the aggregate must be strong, durable, free from slits, organic matter, oils, and sugars. So this is all about the aggregates. The next important constituent of this concrete is your admixtures. So what is this admixture? Admixtures, so we know that the cements, waters, and aggregates are the main ingredient of concrete. There are large number of minerals and chemical admixtures that may be added to the concrete. Okay, we know that. So the concrete, it having the main constituents such as cement, water, and the aggregates, but some material, okay, some minerals and chemical admixtures may be added to this concrete. Okay, so what is the role of these admixtures? If you consider, uh, the first admixture is your water reducing admixtures. Water reducing admixtures. So what is the role of these admixtures? Water reducing admixtures. uh, this water reducing admixture, it is also known as super plasticizers. So this water reducing admixture, it is also known as super plasticizers. Plasticizer. Okay, these are the chemicals that lower the viscosity of the concrete. So what is its function? It lower it lower the viscosity of the concrete. Viscosity of concrete. It lower the viscosity of the concrete in its liquid state. Okay. So this is your water reducing admixtures. Second, that is your retarding admixtures. What is this retarding admixtures? So different types of admixtures are used. Retarding admixtures. If you consider this retarding admixtures delay the setting time. Okay, so what is the function of these retarding admixtures or the materials? They delay the setting time. Retarding admixture delay the setting time which may be necessary which may be necessary in situation where delays in the placement of concrete can be expected. Where delays in the placement of concrete is expected. So these are the retarding admixtures. So it decreases the rate of setting of this concrete material, delay the setting time which may be necessary in certain situation. Then certain color pigments is also added. So the third one, that is your color pigments. The admixture, certain color pigments is also added. Color pigments. So color pigments in powder or liquid form may be added to the concrete mixture to produce color concrete. So what is the function of this color pigment as admixtures? So they are added in powder or liquid form. To the concrete mixture to produce color concrete. Okay, they are usually used with white Portland cement to attain their full coloring potential. So they generally used usually with white Portland cement. So this concrete point is also important regarding to the cementitious material. Okay, so no doubt we discussing it in composite material, but it is also important in your cementing material. Okay, cementing material as a shaft. So this is color pigments. So some admixtures are added. It is water reducing retarding admixtures, color pigments. Some accelerating admixtures is also added. So what is the function of these accelerating admixtures? And accelerating admixtures is used to accelerate the setting and strength development of concrete. So the next one is that the accelerating admixtures. The word itself indicates they accelerate the setting and strength development of concrete. So they accelerate setting and strength. They accelerate the setting and strength development of the concrete. Okay. Generally, the most commonly used accelerating admixtures, that is your calcium chloride, CaCl2. You should keep in mind. Okay. The accelerating admixtures, they are useful to accelerate the setting and strength of the concrete material. And the important, most commonly used accelerating admixtures, that is your CaCl2, calcium chloride, and some mineral admixture is also added. The last one is your mineral admixtures such as fly ash and the granulated iron blast furnace slag are the important mineral admixtures for use in concrete. Okay, they may be replace the portion of cement in concrete mixture, and this replacement is usually made economically. Okay, so we already discussed the cement is an important constituent of this concrete. Then we discussing the aggregates, what is their composition, okay, their classification based on the sources, that is natural and artificial. Then we discussing the admixtures. So what is this admixtures, their roles, okay, water reducing, then retarding, color pigments, then accelerating admixtures, and then the mineral admixtures. The last one is mineral admixtures, in which we add fly ash and granulated iron blast furnace slag. Okay, so this fly ash and blast furnace slag are the important mineral admixtures that are used in concrete, and they may be replace the portion of cement, and it is economically, it is very useful. So this is all about the concrete. In the next lecture we discuss the second important composite, that is asphalts, and in the next lecture we're discussing the application of this composite material. Thank you.